So we are on the second formative, which is actually formative 2. We are explaining in context. So I want to explore explaining slope in context and explaining y-intercept in the context of the problem. So Joe sells lottes at a fair. Find the key characteristics of the graph and then describe the graph within the context of the problem. So we're going to identify the slope, explain it, identify the y-intercept, and explain it. So finding slope, remember, is rise over run. Rise is y values. Run is x values. What do the y values represent? Well, y values represents the money earned, and the x values represent the lots sold. And yes, I know that I'm definitely saying that wrong. All I know about them is that they're a food. I have no idea what kind of food, and I know that I'm saying it wrong. So I apologize, and if you're making fun of me, that's okay. Okay, so what do we rise? So let's calculate our rise. So from this point to the next nice point, we went up 2 units. So plus 2. And our graph is scaled by ones because the next point is 5, so 0 to 5. So I'm counting by ones. And then we went rise, and then now we need to go run is plus 1 as well. And our graph, again, is scaled by ones, so I don't need to change the scaling or change my numbers based on the scaling. So rise over run is 2, up 2, and right 1. So that means my slope will be, I'm running out of room, but 2 over 1, or you could write it as 2. It's totally up to you. But now we need to explain in the context of the problem. So the 2 represents the money earned. So $2 earned. And then usually the fraction bar indicates a per. So let's see if it makes sense. And then the y value or the x values represents the lots sold, and we sold 1. Okay, now that we have that kind of just that formula plugged in, let's check to make sure that our answer makes sense for what I'm saying. Or if I need to change my wording a little bit, now would be the time to do it. Now that I have like the structure of what I'm trying to say. So $2 earned per 1 lot sold. So that means that each lot costs $2. Okay? Or I guess Joe is actually selling them. So let's change that. Hold on. Okay, each lot. No, let's erase that too. Okay. Let's say Joe makes $2 for each lot he sells. Perfect. Okay, that makes a lot more sense than like my bare bone structured explanation. Okay, then y-intercept. Y-intercept is where my line crosses the y-axis. So I'm going to erase this right here. That would be this point right here, and it's 0, 0. So my y-intercept is going to be 0. Remember, x, y is my coordinate, so 0, 0. X represents the lot sold, and y represents the money that Joe earns. So explaining in the context, Joe makes $0 if he sells 0 lots. Okay, perfect. All right, let's go on to number 2. An elevator in a high-rise building moves upward at a constant rate. The table shows the height of the elevator above the ground floor after various times. Our first task is to determine the average rate of change for the problem. Average rate of change is just a fancy word for slope. And then interpret the slope in the context of the problem. Again, in case you've been sleeping, I'm going to explain slope yet again. It is rise over run, and it's the difference of the x values over the difference of the y's over difference of the x's. Time is x, height is y. So it's going to be height over time. Okay, so let's calculate difference of the x's and then the difference of the y's and plug it all in together. Okay, so from 1 to 2, we add 1, 2 to 3, we add 1, 3 to 4, we add 1. And then feet, y values, 12 to 24 is plus 12. 24 to 36 is plus 12. 36 to 48 is also plus 12. So then we'll plug those in. Y value is plus 12. The change in the x is plus 1. So our slope is 12 over 1. The y represents the height in feet over the x, which is time in minutes. So let's see, let's explain that in the context of the problem. We'll use that same kind of setup that I used in the first problem. So we'll go 12 feet per 1 minute. And then explaining it a little bit further in the context of the problem. What's 12 feet per 1 minute? What is that? What are we talking about? Remember, the elevator moves upward. Okay, so the elevator goes up at a rate of 12 feet per minute. Okay, and then write a function that models the table of values. So function, remember, y equals mx plus b. So we need to figure out our slope and our y-intercept, which is when x equals 0. We already have our slope, which is 12 x plus b when x equals 0. So if I go to my chart, I actually don't have 0. I need to find 0. Okay, so to go up, we had to add 1. To go down, I'm going to subtract 1. Okay, so to go this way, I'm going to subtract 1 so I can get to 0. And then I'll do the same thing. I need to go up 1. So to go down, I had to add 12. So to go backwards, I'm going to subtract 12, and I'll get to 0. Okay? So now when x equals 0, y equals 0, which makes sense. 0 seconds, we're at 0 feet. Okay? We're on the ground level. We haven't gone up any. We're not starting in the air. Makes sense. So then we'll plug in our y-intercept, which is 0. So if we wanted to be super thorough, function is actually f of x equals 12x plus 0 doesn't mean anything. So I don't have to write it in. It doesn't really change anything. I can leave it as f of x equals 12x. And then use this function to determine the height of the elevator at 14 seconds. Remember, time is an x value, so when x equals 14. So f of x equals 12 times 14. I should say f of 12. So 14, I'm sorry. So many mistakes. Okay, f of 14 equals, and I'm so bad at my mental math, so I'll just use my calculator. 12 times 14 is 168. Remember to answer with units. So this is 168 feet at 14 seconds. Perfect. Okay, and we're on the next page. Number 3, biggest loser contestants on average start weighing in at 328 pounds and lose 22 pounds per week. The scenario is modeled with the formula A sub n equals 306 minus 22 times n minus 1. Rewrite the explicit form of the sequence using function notation. So let's rewrite this just exactly like we see it, 22 times n minus 1. And we're going to change this A sub n to f of x, or actually let's start with y. I'm just going to add a step in here. Y equals 306 minus 22. And I'm going to replace n with x, because I want it to eventually look like y equals mx plus b. And then from there, I'm going to go f of x equals mx plus b. But students typically in the past haven't really liked f of x, writing that. They view it as 2 different variables when it's all just one thing. It's like having 2 first names. Like Anne Marie is like the first one that comes to mind. It's a first name. It's just 2 names put together to create one name. That's what y is like. Y and f of x, it's one thing with just like 2 names to it. Okay, so then I need to rewrite it so it's like mx plus b. So I'm going to distribute the negative 22. I'm going to get rid of those parentheses. So y equals 306 minus 22x. Negative 22 times negative 1 is plus 22. Y equals, I'll combine like terms. 328 minus 22x. And then I'm just going to rearrange it so the x comes first. Y equals negative 22x plus 328. And then, because they want function notation, I actually want f of x instead of y. So f of x equals negative 22x plus 328. And I accidentally went into the other problem, so I'm just going to shrink this down so that it all fits. And that's all I needed to do. Part B, how much on average will a biggest loser contestant weigh after 6 weeks? So weeks is an x value, so when x equals 6, let's evaluate. So f of 6 equals negative 22 times 6 plus 328. And I'm just going to plug that all into Desmos at once. Negative 22 times 6 plus 328. So f of 6 equals 196 pounds after 6 weeks. Perfect. That's some pretty good weight loss. Miss Marlega's ginormous pumpkin spice latte is 400 ounces. She drinks 40 ounces per hour. The function P of T. P of T is just like f of x. It's just a different first name. Equals negative 40t plus 400. And it describes her ounces remaining, P as a function of time in T hours. So T represents time in hours, and P of T just represents the amount of ounces remaining in her pumpkin spice latte. So we need to graph the function that describes Miss Marlega's latte and then label the x and y axes. So we're really graphing y equals negative 40x plus 400. And this is our slope, and this is our y-intercept. X values, let me change colors. X values are going to represent time in minutes, And Y values are going to represent her pumpkin spice latte remaining, and it's measured in ounces. Okay, and then from there, I can label my X and Y axis. So time in minutes, and then the Y is pumpkin spice latte remaining, measured in ounces. Okay, so then I'll graph my y-intercept, which was 400. That's where I'm gonna start. My slope is -40, so I'm going down 40 and over 1. My graph is scaled by 20s, so I'm actually gonna go down 20, 40 over 1, down 20, 40 over 1, down 40 over 1, down 40 over 1, down 40 over 1, so on and so forth until I reach the bottom. And then I will connect those lines together, or those points together, to make a line. Interpret the slope and y-intercept in the context of the problem. So the answer is actually given to us in the word problem initially. So Miss Morlega's ginormous pumpkin spice latte is 400 ounces. The 400 was our y-intercept. So the y-intercept is 0, 400, because Miss Morlega starts with 400 ounces of pumpkin spice latte initially. And then her slope is going to be what? -40. So that's what she drinks per hour. So the slope is -40 because she's drinking 40 ounces per hour. So she drinks 40 ounces per hour. And then the last one, use your function to determine how much latte Miss Morlega will have left after 4 hours. Oh, I thought that was minutes. Oh, I guess I had her drinking way too fast. Okay, let's change this to hours. Sorry for the confusion. And then this should say hours as well. Okay, my bad. All right, so x equals 4. So I'm going to use my equation. Y equals -40x plus 400. We'll plug in 4. Y equals -40 times 4 plus 400. Y equals -160 plus 400. I definitely could have plugged that into my calculator. So -40 times 4 plus 400 equals 240. I want you to explain in the context of the problem. So 240 ounces remaining after 4 hours. Okay. It also should match my answer on the graph, 4 hours, 240. Perfect. So I know my math is correct.